Hi everyone, welcome to the video over properties of logs. So getting into our properties, it says let b, x, and y be positive real numbers and b can't equal 1. So our first property tells us that log base b of b equals 1. So let's think of why this is true. So if we convert this into exponential form, remember I have my base raised to my exponent, which is on the opposite side, so raised to the first power, equals the number that's with the log, which would be b. So b to the first power equals b. That's why this property works. So again, log base b of b equals 1. Property number 2 says log base b of 1 equals 0. So if we think about it, my base is b, the exponent would be 0, and it equals 1. Well, anything except 0 to the 0 power equals 1, so that is why this property works. Looking at number 3, log base b of b to the x power equals x. So again, that relates to property number 1. My base is the same as the number with it, so it's equal to the exponent. Okay, so if we convert this into exponential form, we would have b to the x equals b to the x. Remember when we were solving, we set, if our bases are the same, we can set the exponents equal to each other. So it would just be x equals x, which is what we got. Okay, same concept if it is in exponential form, like property number 4. B to the log base b power of x equals x. So my base of the exponential matches the base of the log, just like in example of 3. The base of my log matches the base of my exponential. So the x is what my answer is. So looking at our first 4 examples on example 1, we have log base 4 of 4. So that would be property number 1. And my answer would just be 1. Okay, you could also type this into the calculator if you weren't sure, so I will show you how to do that. So if I grab my calculator, I go to a new calculator screen, and I'm going to add a calculator. If I type in log base 4 of 4, I get 1. So you can always check these with your calculator if needed. Okay, looking at number 2, it said, or sorry, letter B, 2 to the log base 2 power of 5. So my base of the exponential is the same as the base of my log, which means this right here is my answer. So it would be 5. That would be property number 4. The next one, log base 125 of 1. That is going to equal 0. Again, you can always use your calculator to confirm this, but any log of 1 is going to be 0. That is property number 2. And then lastly, log base pi of pi to the 8th. My base of the log is the same as the base of my exponential, so that 8 is my answer. And that is property number 3. So again, all 4 of these could have been checked with the calculator. Now, moving into the properties that is going to help us with solving equations. Okay, so these are the super duper important ones, not that the others weren't, but these are the ones we're going to see more often, and these are what are going to be on our test. So the product rule says that if I have 2 things, okay, being multiplied on the inside of the log, then I can split them up into 2 separate logs by addition. My bases will stay the same, but I split it up by adding x and y. Okay, so making sure that you understand that it doesn't mean if I'm multiplying log base b of x times log base b of y is this. Okay, so notice how the multiplication happens within a single log. So we're going to have to work on going and expanding it like this way over here and condensing it to look like this. So you have to be able to go and switch it between both forms. The quotient rule says that log base b of x divided by y, so this is where there is a division, okay, then I can split it up by subtracting. Okay, so addition and multiplication go together, and subtraction and division go together. And then this last property says that the power rule, okay, that says if I have a power, an exponent raised to a power, then all I need to do is I can bring it out in front of the log and it becomes a constant there. Okay, so we're going to work on expanding first, and then we will go into condensing. So I want to expand this. Notice I have two different variables. So since I have two different variables, then I'm going to end up with two different logs when this is expanded. First thing we need to take care of is that we need to know that the square root of y, is equivalent to y to the 1/2 power. So we do need to make that change first. The square root of y is equal to y to the 1/2 power. So I'm going to go ahead and make that change before I start expanding. And we do see that they are being multiplied. Okay, so now since they are being multiplied, that means I can separate them by adding. So I'm going to have two logs in this step. My first log is going to be with x to the 3rd power, and I'm going to add my second log with the same base with y to the 1/2 power. Okay, so that was done by using the product rule, which is rule number 5. Okay, now I see that I have some exponents, and all we're going to do to finish this problem out is to move those exponents out in front. Okay, so what that looks like is I will have 3 log base 2 of x plus 1/2 log base 2 of y. And we did that by the power rule. Okay, so notice how each log has its own variable, and we took the exponent and made it the constant in front. Okay, now parentheses, if you want to put parentheses around the x and around the y, that's fine. But if you leave them off in a case like this, that is fine as well. It just, if there's more than one variable with the log, then there needs to be parentheses. But you can leave it with or without parentheses for this example for your final answer right here. Now, the only thing that I could see that might look different for the final answer is if you have log base 2 of x, and then it's plus log base 2 of y divided by 2. That is the only other way that I could see this written that may look different from what we came up with. Okay, looking at example B, I have 3 different things. Okay, so I have the cube root of x, that's 1. I have 100, that's a second different thing. And then I have y to the 6, so that's 3. So I should end up with 3 different logs. So we're going to start by recognizing that the cube root of x can be written as x to the 1/3 power. So we're going to make that change first. So I have log of x to the 1/3 power over 100 y squared, or y to the 6, I'm sorry. So when we do one like this, we're going to start with this division right here. Okay, so what that looks like is log of x to the 1/3 power minus log to the 100 y to the 6th power. Now, I said we should end up with 3 different logs, and right now we only have 2. Okay, and again, if you want to put parentheses around this, you can. Okay, now, how we get the second one is this piece right here. Those are being multiplied. So to separate those, we're going to add a plus sign. But we have to understand that that negative's in front. So when we do this, we get log of x to the 1/3 minus, and we need to put parentheses around it. So we have log of 100 plus log of y to the 6th. Okay, so then we can distribute that negative. Okay, so if we distribute that negative like this, boom, boom, it gives us log of x to the 1/3 power minus log of 100 minus, so let me change those minus signs to purple. So minus log of y to the 6th. So eventually, when we start getting more comfortable with these, we can cut out this step and go straight to this step right here, where we recognize since there's 2 things in the bottom, then both things will end up having a minus sign with it. But until we feel comfortable, then we have that intermediate step. Now, so let me go ahead and write down the properties. So first thing we did was the quotient property. And then the one that we just did was the power property. Not the power property, the product property. And then our last and final step is that we see that this is an exponent right here. So we can go ahead and bring that out in front. And then at the same time, I want to simplify this right here. So we're going to type that into the calculator, log of 100. So when I go to my calculator, I just hit log. I don't have to worry about a base because the base is not there. So I type in log of 100. It tells me that it's a base 10, but it should equal 2. So I'm going to change that value to 2 as I drop down my exponents. So I'm going to continue my work over here because I ran out of space. So I'm going to have 1/3 log of x minus log of 100, we just said was 2, minus 6 log of y. And that would be our final answer. So if there is a number, then you can simplify it like log of 100. So this was the power rule. Okay, so when there's numbers, you can simplify. Okay, looking at the next one. So I see that I have 2 things up top being multiplied, and then I have division and 2 things on bottom being multiplied. So the things on top will get a plus sign in the middle. Anything on the bottom will have a minus sign in front of it. So again, the 2 things on top will have plus signs. The things on bottom will have minus signs. So what this looks like. And since I have 4 different terms, x, y, z, and e, I'm going to have 4 different natural logs. So we have the natural log of x to the 3rd plus the natural log of y to the 5th. Now I move to the denominator. They get a minus sign, minus the natural log of z to the 6th. Okay, now the e, remember those were being multiplied. That would be the step like this up here, where I'm going to skip it and just go ahead and give it that minus sign that we got after we distributed. So it's going to be minus the natural log of e to the 2nd. Okay, so this was the product and the quotient rule in one. Now, the only other thing that I see is that these have some exponents here, here, and here, which means they can be dropped down. Something that we may forget is that e is a number, so this actually can be simplified. Okay, so we're going to do those in the same step. So I get 3 natural log of x plus 5 natural log of y minus 6 natural log of z minus, I'm going to type that in, the natural log of e squared into my calculator. So natural log of e squared is just 2. It's because the base of the natural log is e and my base of my exponential is e. So we get 2, which was just the exponent. And this right here would be completely expanded. Okay, so you do have to be able to expand like this. And then you're also going to have to be able to condense, so doing the opposite of what we just did. So now we're going to be working backwards. Okay, so first thing we see when we're trying to condense is that I have two logs, and I want them to become one single log. So we start by moving anything that's in front of the log and moving it back to its exponent. So it's the power property in reverse. So that gives us the natural log of x to the 1/2 power plus the natural log of y to the 3rd power. Then I see that I have a plus sign in the middle, which means when I put the two logs together, they will be multiplied. So that will give me x to the 1/2 power times y to the 3rd power. And then the last thing we need to do says right here, convert rational exponents to roots, meaning I see that I have a 1/2, which means I need to convert that back to the square root. So the final answer for this right here would be the natural log of, I'm going to bring the y out in front just so it doesn't get confused for being underneath the radical, and then the square root of x. Okay, moving on to our next one. I see that I have numbers in front of each of my logs, so I'm going to move those to all be exponents of the variable that it's with. So we have log of x to the 1/2 power minus log of z to the 3rd power minus log of y to the 1/4 power. Now, I see that I have 2 subtraction signs, which means both of those things are going to be in my denominator whenever I condense it to one single log, and the x will be in the numerator. So we have log of x to the 1/2 power divided by the two things that were in, or the two things that had minus signs, so z to the 3rd and y to the 1/4. So it's going to look like that. So if you think about it, if we were to factor out a negative sign from what is highlighted, there would be, this would change into a plus sign, and so that's why they're being multiplied on the bottom. Now, all I need to do is take care of these rational exponents and make them roots. So I have log of, we know that 1/2 gives us the square root of x. We have z to the 3rd, and 1/4, instead of being the square root, it's going to be the 4th root of y. And that right there would be our final answer. Okay, so if you're having any questions during this, please make sure you're writing them down. That way you remember to ask them. So if you want to pause the video and try to do this one on your own, go ahead and do so, and then you can check your work with the final answer that we come up with. So here we go. First thing we do is we start by any numbers in front of the logs. We move them up to be the exponents. So that gives us log base 4 of x to the 7th minus log, base 4 of y to the 1/2 power plus log base 4 of z to the 5th power. Now, I see that I have a minus sign, but I also see that I have a plus sign. So, in the numerator, the x and the z will be up top being multiplied because those are both positive. The y will end up being in the denominator because it has a minus sign. So we write it with one single log. We're going to have our x to the 7th and multiplying it by our z to the 5th because those both have plus signs in front of the logs. And we're going to divide it by y to the 1/2 power because the y to the 1/2 power had a minus sign. So I'm going to go ahead and put my parentheses around this. And then the one thing that I see we need to do is we need to fix this right here to be a root. So we get log base 4 of x to the 7th, z to the 5th, divided by 1/2 gives us the square root of y. And that would be our final answer. So what you should notice is that when we expand, however many logs we have is however many terms we had. So in A, we only had an x and a y, so we had 2 terms. In B, we had an x, a number, and y, so we had 3 different logs, but then the number ended up simplifying. In C, we had an x, a y, a z, and an e. So we had 4 different logs, but then the e simplified, so we got a number. When we're condensing, okay, you're condensing everything into one single log. One single log, okay? The last property we have is the change of base. So what this tells us is we can change the base of our log to anything we want as long as we follow this. How we do this is we do the log of our number over the log of our base. Okay, the new base in this change of base formula can be anything. Typically, when we do this, we like to use the natural log and the common log because those are just easier to work with. And sometimes our answers are just left in change of base form. So we're just going to practice. So again, this can be any base. So if I have a base 7, like I see in example 3, and I wanted to change it to a base 5, all I got to do is do log base 5 of 82 over log base 5 of 7, and I changed its base. Okay, so you can change the base to any number, but typically we just like using the common log and the natural log. So in example 3, we're going to rewrite log base 7 of 82 using the common log and the natural log. Remember that the common log is a base 10. It looks like a log with no base. The natural log is a base e. That is where we use the ln. Okay, and then we're going to evaluate. So first we're going to start with a base 10. Or let me just call it the common log. So we'll say base 10, which is the common log. So we have log base 7 of 82. Okay, so when we do this, our a in the formula above is going to be 10 because it's a base 10. Okay, so we have log of our number, which is 82, over log of our base, which is 7. And that's it. That's all you have to do for change of base. Okay, And again, a log with no base is a base 10. So now we want to do the base e, which is the natural log. Okay, so a is going to be e, our base e. So we have log base 7 of 82 is equal to the natural log of our number over the natural log of our base. And that's it for change of base. That's all you have to do. Okay, so now we're going to evaluate it. And I'm going to show you how to evaluate all 3 of them to show you that this works. So first we're going to start by evaluating log base 7 of 82 using our calculator. So we have log base 7 of 82. So I'm going to go to my calculator. I'm going to hit log base 7 of 82. Press enter. I get 2.26, and then that last 6 is going to make that 4 become a 5. So 2.265. So let's write that down. 2.265 is what we get when we evaluate. Now, I want to show you that when we evaluate log base 82 over log base 7, we get the same thing. Okay, so log of 82, give me my fraction of log base 7. So again, I did not type in a base because we did not have a base, and it's a base 10. If you want to type in a 10, you can, but if you don't, it does it for you. And notice I get the exact same answer, 2.26461. Okay, if I switch it to the natural log, so the natural log of 82 over the natural log of 7, I get the same exact thing. Okay, so that's why the change of base works. It's not saying that the log base 10 and the log base e, the natural log, are the same thing. It's just saying mathematically that's what we're doing. These expressions are equivalent because we're using the change of base formula. So that's how you can use the calculator to check your work. That is how you do change of base formula and all the other properties. So if you have any questions, please make sure you write them down so you can ask me in class the next day.